Hello everyone, welcome to edspread. So here we come up with SQL Bootcamp. So SQL Bootcamp, and SQL is nothing but structured query language. Okay, and structured query language that we are going to use the database management system to access the database management system and to insert, update, delete, and alter the the database. So first we are going to learn about what is a database. A database is a collection of data that is organized, which is also called as structured data. It can be accessed or stored in a computer system, right? And it can be managed through a database management system that is nothing but DBMS, a software that is used to manage data. And database refers to a related data in a structured form, right? So there are different types of database. So you are going to learn only 6 of database. There are other databases too. Now there are a centralized database, a distributed database, cloud database, a relational database, NoSQL databases, and open source databases. Now all these we are going to learn and know about them. And the relational database is an important one because we are going to learn about it in the next 7 days. And here it is. Now, what is a centralized database? It is in a centralized location, and users from different backgrounds can access this data. This type of computer databases store application procedures that help users to access the data even from a remote location. Now, what is a centralized database? Now, as the word says, all the data that is being that is being accessed from different users that is being accessed from different users is in a one particular centralized location, and that is being accessed via internet. I mean, using internet. So using internet, they are going to access the data which is stored in a particular centralized location. So that is a centralized database, and there are some advantages and disadvantages for using centralized databases. One of the advantages is that it's easy to use, and uh, it as the internet is accessed in as the internet can be accessed from any remote location, you can use it from any remote location. And there are some disadvantages too. One of them is that if there is a problem with the internet connectivities, like with the database system, I mean, where the data is stored, where the data is being stored, then even the client or the user who is accessing the database will have a problem. So that needs to be placed, and there are some problems known as bottleneck. That is a technical word. It means that it will be, for example, to explain the bottleneck, I'm going to give you a small example. Now, if you are going to check for results, eh, when you're going to check for results online, so after some particular users, it will show some errors, or the page wouldn't be appearing to us. So that is nothing but a bottleneck problem. Only some particular users will be able to access at that particular time. So that will be a problem in a centralized database system. So this all, as I said, you have given you only uh, two advantages and two disadvantages. So there are many advantages and disadvantages in a centralized database system. Let's go to the next database system. That is nothing but the distributed databases. Now, from the centralized and distributed, I understand that you get the difference. Now, the distributed database system is like the data is stored in a 2 or 3 different locations. So when the client or user wants to access that data, he'll access that particular location, only one particular location, not all the locations, from that particular location, and get the data from that particular place. Or he will access 1 or 2 different places and take that data. Okay, now let us read what is there over here. A distributed database is a type of database that has contributions from the common database and information from captured by the local computers. So, as I said, the local computers are nothing but uh, these local computers. I mean, uh, the computers or the which are able to access the data from that particular location. That is nothing but the local computers. In this type of database system, the data is not in one place and is distributed at various organizations. So not or one, two, or three places. There are a number of locations. So that distributed databases have some examples, but if the data is being he needs to access from one local computer to some other database, there will be some problems in this too. So you can browse and you can get it. I mean, it's good, right? And coming to the next database, cloud database. A cloud database, I guess you heard about this cloud database or a cloud thing. Okay, okay, let us read what is there here. A cloud database is a database which is optimized or built for such a virtualized environment. There are so many advantages of a cloud database, some of which can pay for storage, capacity, and bandwidth. It also offers scalability on demand along with high availability. Now the data is being stored. Cloud is nothing but the data is being stored into the cloud. Okay, cloud is nothing but information. Okay, in information here it is in one particular location. See, so here cloud. So as the clouds that you see in the sky, in the same way it can be accessed from any place. It can be moved not in particular location. It will be, I mean, clouds move from one, the clouds in the sky move from one place to another, like, and another. So in the same way, here the cloud also moves from one place to another, which will be very accessible and very easy. And as here it is there, it is for storage capacity, some of which can the capacity of the storage can be increased. The bandwidth of the data, I mean, the movement of the cloud can be increased, means more people can be able to access the cloud, the data stored in the cloud. And it can also scalability on demand. More data can be stored, making it a bigger cloud. See, more water is there in the in the sky, the clouds. If there is more water there, the size of it will be more. So in the same way, the scalability on demand along with high availability, the availability will be more, obviously. So this is about the cloud database. Next, coming to the relational database. Okay, relational database. This type of database defines database relationships in the form of tables. It is also called relational DBMS, which is most popular DBMS type in the market. Database examples of the RDBMS system include MySQL, Oracle, Microsoft SQL Server database. Now, the bootcamp is about this relational databases. Now, this relational databases can be used in banking applications and universities and marketing, etc. Now, according from the company to company, it changes, but most of them use relational databases. Now, we can use the relational databases in MySQL, Oracle, Microsoft SQL, and Server database. Now, this relational database, we call it as RDBMS here. Okay, and connections from database to database, the relations from database to database. So this whole part is usually sometimes in a cloud, is usually sometimes in a from one particular only, like what do you call it? Yeah, centralized database, or sometimes distributed database, and anything. I mean, it can be anything, but it is very useful, and many companies use it for storing their data, and it is, yeah, that's it. So next, coming to the NoSQL databases. NoSQL database is usually large sets of distributed data. There are few big data performances that are very effectively handled by the relational databases. This type of computers is very efficient in analyzing large size of unstructured data. So it's no SQL database. Now, for using the DBMS, we use something known as the structured query language. In short form, we call it as SQL. So without the SQL, without using the SQL, without using the structured query thing, we are able to store data, and that is nothing but the NoSQL database. It is not for small things that we do. I mean, for a very large amount of data, we use NoSQL databases for analyzing the data for something like for a big corporate where it's selling its big things like bigger supermarkets, etc. Then we are going to use the NoSQL databases, and it's less used, but very less used in fact. Open sources databases. These kind of databases store information related to the operations. It is mainly used in the field of marketing, employee relations, customer service, or the database. Okay, about this kind of database stored information related to the operations, field of marketing, employee relations, customer service, or the database. Open source is nothing but anyone can access this database. Anyone from anywhere can access this database. So there will be, yeah, that's it. Now coming to the database components. Okay, now the database components include hardware, software, data, procedure, and data access language. Okay, now the access spelling is wrong here. Okay, the hardware. The hardware is nothing but a computer or a laptop that is actually need to store the data. So store the data and they access the data. So that is nothing but the hardware. Now coming to the software. Now as there are some examples here, we are able to access the data. We are able to insert the data. We are able to access the data, retrieve the data, delete the data, and perform operations on the data using these particular using these things: MySQL, Oracle, Microsoft SQL Server. So using these applications, using these compilers, that is the software that we are going to use to access the data that is being present in a cloud or a centralized database or a distributed database or whatever, however the data is being stored. And coming to the data has to be accessed, right? The data needs to be stored somewhere to access, to see, to insert the data. So that data has to be accessed. That is nothing but the data written over here. And next, coming to the procedure. So how the data is being inserted into the first thing that needs to be inserted into the database. And next, it needs to be accessed to the database. It need to be, again, if there are any changes made to the database, that has to be retrieved. And sometimes it needs to be retrieved. It sometimes need to be completely deleted. So all this part needs to be done via procedure. Now, with the data access language, again, we need the hardware, software, data, procedure, and the data access language that we are going to learn about. So it's a complete cycle. So we are going to need every one of them to complete the database that we are going to learn. We need all of them. And all the corporate companies or the software companies, the hardware companies need the database management systems. So every one of them, every user who's trying to use this database system needs to have these all things, need to have these components. And the next, coming to the database management systems. Database management system is a collection of programs that enables its users to access the database, manipulate the data, report and represent the data. It also helps to control access to the database. Okay, now let us take this. Access the database, manipulate the data, report and represent the data. Okay, first thing, access the database. I guess you have understood that point. Manipulate the database. Now manipulate the data. Once you have accessed the database, you have seen the database, you should be able to manipulate the data. Manipulation is nothing but changing the things that are already there in it. Means changing the, for an employee, changing the salary, changing the if he is in a, if he got a promotion, he needs his salary to be updated, and he needs to set to 10%. He needs to set it to another, I mean, he needs his salary to be increased by 10%. According to the salary, again, the tax deductions will vary. Now, again, if he is getting a promotion, there might be a transfer too. So about that particular transfer thing, they needs to change. They need to change about his location that is somewhere stored in the database. Again, they need to manipulate the data. They need to change the data that needs to be done. And if there are if the place is being stored, and if there is no transfer, he moves from one room to the other as his position increase. So that place where he sits needs to be changed, which is also stored in the database. So again, that data needs to be stored. And coming to the report is nothing but the data that is being shown in the data when it is accessed. So that needs to be stored. And to represent the data, again, when we want, I have changed it from one particular location. Now I have changed it, and some other person wants to view the data. When he is able to access the data, that particular thing needs to be shown. The changes that I have done also should be shown, right? It shouldn't be again the same data that I have not accessed before. The same database again, to save the data that needs to be there. And the other person might be seeing with some changes who all got promotion. With that particular criteria, he might be checking on how to represent the data, and it also helps to control access to the database. Now, coming to this point, now if you want to check your bank account balance, now how do you check that bank account balance? Let us assume your bank has an phone app. So with that particular app, when you give your credentials, they're able to access your database. You are able to access your bank account balance. Now, when you're doing this, you will be able to see only your account balance only, not others' bank account balance. And none of the details, where the bank name, the bank, where is the amount stored, and for which all transactions that you have done. No, only the thing that you have searched for, and only the thing that you need to see, not about the bank secrets, everything. You'll not be able to see where the data is being stored, or some other person's bank account balance, everything that is not shown to you, because the data that you're accessing is being limited only to you, right? So it and if a person from a bank wants to check your details, he'll be able to get many details, like to which all bank accounts did you pay them, to which all bank people did you pay the money, to which all transactions have you made, to which, what is your Aadhaar card number, what is your bank account number, have you taken any loan from the account. All these details, he'll be able to access the database. He'll be able to have the access where we are not able to see we being a customer, we are able to access only some part of the data. He being the employee of the bank, he'll be able to access to the database. Now again, if there is some other person, he'll be able to check the joint loans, the amount, everything he'll be able to access. Now that is these, if the manager wants to check, he can check many of the things too. So it also helps to control access to the database. The next part is, in previously, before this database management system, we have used something known as the file-based system. Now, the file-based system is different from database management system. I'll give you an example. Now, for example, if you want to create a table, now you can create tables, everything that can be done in an Excel sheet, or it can be done in a Word format, or it can be placed in a PPT, right? It can be placed in a PPT, or it can be placed some other where. Now, all these file systems it can be written in any, the data can be stored, the tables can be made, and the data can be stored in any of these file formats. But in any of these file formats, and you may not use one particular file to store all the data. You might be using one for one part for PPT, one part in Excel, one part in Word document. So in all the things you can store. But when you're accessing the data, it becomes hard for you to access four files, 5 files, 6 files to access, to get what you're looking for, to be searching for what you, I mean, the accessing will be difficult. And in the file-based system, there will be some there are multiple file formats, and to get the data from different formats differently, you need to write the code differently, which will make your work hectic, right? And so they thought in 1960s, and more developed in 2002. I mean, the version that we're using is that has been developed in 2002, 2004. But the idea of the database management system had been implemented from the 1960s itself. They have the idea, they have been developing, and that one we are using is more commands are from the 2004 version. And even those are being updated, but still we are using the 2004 commands with a little updations. But the idea of the database management system, as there is a problem with this particular part, they have been idea and started using the database management system. So I have given you only one examples where the files are not comfortable. Now the problem, and the other problem is that now the people who are able to access the database will also have a problem. Means only some things should be shown to only some people. I meant all the database shouldn't be in the previous examples what I've said to you. The when you're checking your bank account balance, only your bank account balance should be shown to you, not of the any others. So to control the database means only the customers will be able to see only this particular things, and the bank employees will only be able to see these things. The manager of the bank will be able to see only these things. The higher authorities will be able to see only these things. So control over the access to the database. Again, they need to write code differently for different file formats, and there will be a hectic work. Now we are going to discuss about we have already started discussing about the file systems and how it is disadvantages. And what I'm going to tell you is that every problem in the file system has been made better in the database management system, making it has been improved in the database management system, making it easier to use. See, all the problems, all the drawbacks over there, he has made that in the DBMS, he has made it as an advantage over here. So I'm going to say some of it to you. Now, again, there is a problem of data redundancy and data inconsistency. Now the problem is that there are multiple file formats that I've already said you in PowerPoint I can write a table, in Excel I can do a table, in MS Word I can do a table. This is just an example. The different types of files were used for database at that point of time. So using for accessing the different files, there used to be a problem. And if there are relationships among these different file systems, we need to write code differently. For accessing the data, the file systems, they need to write code every day. I mean, they need to write code every time they want to access the data, which is actually a problem. But if there is a different file system, there is more problems, and there would be a data redundancy, means a repetition of data will be there, and that would sometimes even affect the database, making it is inconsistent. Okay, inconsistent. Now let me say you some words about let me say you some important points about the database management system. That is nothing but remember the word remember the word acid. Okay, remember the word acid. Now A stands for atomicity, C stands for consistency, C stands for consistency, I stands for isolation, and D stands for durability. I stands for durability. Now, this is a very famous mnemonic that is used for the database management systems in the interviews too. So, as the word says, atomicity. Now, the atomicity is also a disadvantage in the file management system. So, atomicity. Now, I'm going to give you an example where this atomicity, where you can understand the atomicity. So, if there are two persons, let's name them person A and person B. Now, person A is having 100 rupees in his bank account, and person B is having another 100 in his bank account. Now, the person A wants to send 50 rupees from to person B. So, what does he need to do? He just opens Google Pay or Phone Pay or Paytm, and he just sends on 50, and the money goes. That is seen to him. But what happens to the transaction over there is nothing but it mainly performs 6 different operations. Remember, 6 different operations. And if these 6 different operations do not perform, then if each one of these 6 didn't perform, the transaction shouldn't happen. See, I'm going to say how it's going to happen. Now A wants to send 50 to person B. So what does he need to do? First, the amount of the bank balance amount should be greater than 50. So the amount of A should be the amount that is present in the bank account A should be read by the bank or the Google Pay, and that amount should be greater than 50. Once it should read A, then it should subtract 50 from bank account A as he or she wants to send money. So it should be A minus 50, and that A minus 50 means that is nothing but 50. So that A's bank account should be 50, and 50 will be holding by the bank. And at that time, the next process is the bank account of B should be read. It is initially 100 here, so that should be done. And the next process is the 50 that is being holded by the bank should be added to the bank account of B, bank account balance of B. So that is equal to B plus 50, for instance. So B equal to B plus 50, that is 150. So again, the bank balance of B should be changed to 150. So now at the end of the transaction, there are 6 different operations that I've said you. Reading of A, subtracting from A, and writing of A, and again read of A, sorry, not A, reading of B, adding amount to B, adding amount 50 to B, and then writing B. So these are the 6 different operations that need to take place when a transaction is going on. So if there is a problem in reading the bank account balance of A, this transaction should stop. If there is a problem in adding the amount to B, the transaction should be not done at all, and it should be changed to 100. It shouldn't be the amount shouldn't be holding by the bank. Anything that shouldn't happen. So the problem there will be a problem in the file-based system when we want to do atoms. There is no atomicity, so there will be a problem in the file-based systems. So this is an advantage in the database management systems. Then consistency. Now the file-based system is inconsistent. Okay, the file-based system is inconsistent. Now you will get to know what about this inconsistent in your further videos. Now isolation. Now isolation is nothing but the amount of the data that is being only shown to you. Now I can give you an example where I've already said you about this. When you're going to give your account number in your particular bank app, you are going to get information only about your bank balance and nothing else. No one else's bank account details would be displayed to you. Those all details, etc., won't be displayed to you, which will be only displayed to the employee of the bank, the manager of the bank, the person working. So only the customers will be able to view this particular information, the bank balance, their transactions. They'll be able to see. The customers will be able to see their transactions, the transaction that I've done, and the amount that is remaining, etc. So the isolation, the data that is stored only to you people, see, it is isolated from the others. So that is nothing but the isolation and nothing but durability. The data will be lasted for a longer time. They don't need to update the, I mean, every time the update happens, the data will be continuously stored. It will be updated, right? So it will be for a longer time, for longer periods of time. So that is nothing but about the durability. Okay, so it is a very important word, and I request you to remember about this asset. And the next part is, in file-based system, it is difficult to access the data. That is mainly due to, I was all repeated twice or thrice before, there would be different file formats, there would be different difficulty in accessing the data. Now there would be integrity problems, integrity constraint problems. Now that is nothing but, as I said you in the example before, person A and person B. Now if okay, the same person A is in bank balance, for example, in the bank balance, there is some constraints that it should have a minimum amount of 1,000, a minimum amount of 5,000, a minimum amount of 10,000. So if there is if there is a new person C and he wants to make a new bank account, then he wants to enter only 5,000 into his bank account, and when he's entering the 5,000, when the bank employee is entering on the minimum amount is 10,000, and the person in the bank trying to enter only 5,000, there should be some problem that the minimum amount is 10,000, right? So that is a constraint that we are going to give to the database, that we are going that sometimes not possible, sometimes very difficult to do it in the file-based systems. So in the same way, when you're trying to take amount from the bank, from the ATM card, there should be a minimum amount of 1,000 in it. So when you're there is only 1,050, and when you're trying to take 100 from it, there should be a constraint. You cannot take 100 from the bank account. You can only take 50 from your bank account, as the minimum balance that should be remaining in your account should be 1,000. So there are some constraints, right? There might be some other constraint in a university, some other constraint in employees for different companies for differently. But I'm just giving you the examples how the constraints, and it is are literally hard in the file-based systems. And the next part is concurrent access by the multiple users. That is nothing but the same people, I mean, concurrent means parallelly the different people are going to access the database. Now that would be a little difficult. It's need access for concurrent access needed for performance, means the people might be working on the same database at the same time. I mean, for the same database, taking the data. Now if there might be there will be a problem in the file based systems. So the concurrent access by the multiple users was a problem. By then there were only some particular people. It was a very hard thing. And the security problems means the isolation, you can say it. Now all the data shouldn't be seen by the by the person using it. There should be some commands. He should be only able to see it but not change the values. He should not be able to delete the values. Everything, that access shouldn't be given to everyone, right? So there should be some security firewalls, some triggers that should stop the people from doing all those manipulations, only for viewing, only for writing, not for changing the data. Now we can add some constraints. See, as I said before, there might be some constraints that we are going to add to the database. Now for accessing also we can do that, and for that we need security problems, and that security would be a problem in the file-based system, because again, uh, it would be hard in a file-based system. In the database it is handled but in a better manner. So I'm going to give you the advantages of the DBMS. So DBMS offers a variety of techniques to store and retrieve the data. DBMS serves as an efficient handler to balance the needs of multiple applications using the same data. Uniform administration procedures for the data. Okay, application programmers never exposed to the details of data representation and storage. A DBMS uses various powerful functions to store and retrieve data efficiently. Okay, you can remember these points, like it has powerful functions, it can store, retrieve, and data efficiently. The data, we have repeated the point just because you to remember how it is better than the other systems, and it offers data integrity and security. The DBMS implies that the data integrity constraints to get a high level of protection against the prohibited access to data, as I said you in the points before. Okay, a DBMS schedules concurrent access to the data in such a manner that only one user can access the same data at a time. See, some security issues, multiple users, how to limit that, everything that can be done in a DBMS thing. Reduce application development time. Okay, for making the application more user friendly, more better to the one particular software company, one particular hardware company, one particular manufacturing unit, the time will be reduced. It will be better than the file based systems. Okay, now as we have completed the advantages and what you have understood about the different database, the different types of database, different types of databases now, and the database components. Now we are going to learn about the different types, levels of abstraction. Okay, levels of abstraction. Okay, now there are three levels of data abstraction. Okay, the first level is nothing but the physical level. The physical level of data abstraction. That is nothing but it is just shows, okay, it just describes how a data is being stored in a database. Describes how data is stored in a database. The second level is the logical level. Okay, here the physical level part would be there, and the physical level describes how the data is stored and also the relationships among them, and also relations among data. And third level is view level. Okay, view level, it application programs hide details of the data types. Okay, Asian programs hide details of the data types. Okay. So, for example, your bank account balance should be only numbers. It should always be greater than zero. And in some particular bank account, it should always be greater than thousands. There are some constraints. So, okay. Now, that's not the point. The data types is nothing but can be your name is a string. Okay. Your name is a string. Whereas your bank balance account is an integer. Okay, it's not an integer, it is just a natural number greater than 0. So greater than 0 and should be never less than 0. So it is a natural number, and your name of the uh, account holder should be a string. So it hide the details of the data types. We can also okay, as I said you in the examples, views can also hide for security purpose, hide data for security purposes. Right. So these are the 3 levels of data abstraction, and the view level is the highest level of data abstraction. Highest level of the data abstraction, where the logical level is the higher level than the physical level. And this is the lowest level of the data abstraction. Okay. So if anyone is going to ask about the 3 levels of abstraction or the levels of abstraction, you're going to say about this. And the next part is physical data independence. Okay. Physical data independence. Now, if we want to access the data, there should be only changes in the physical level and not in the logical level. Now, the physical level, how the data is being only stored in the database and not the relations. The relation shouldn't change anything, but there should be only change. Okay, there should be only change in the physical level. So if that is possible, then we say that the data is physically independent. It is not depending on anything else, right? It is not depending on the relations. So here we are going to say that it is a physically independent data. So if that is possible for a data, we can say that it is possible for physical data independence, and which is possible in the database management system. It is an advantage. Okay, now I'm going to say about the instances and schemas. Okay, let me say about instances and schemas. Now these are some of the few terms that we are going to learn about. Okay, schema is the logical structure of the database. Okay. Okay, the schema consists of the logical structure of the database, and there are three, you can say, there are two types of, again, schemas. Okay, that is, okay, physical schema. Okay, that is nothing but same as the physical level of data abstraction. The physical schema is nothing but the database design at physical level, and the logical schema is the database design at the logical level. Database design at the logical level. So what is this physical level and the logical level? That is nothing but how the data is being stored in the physical level, and the relationships among the data is nothing but the logical level. So it is very easy, and it is analogous to the type of information available in a program. Okay, the schema is always analogous to the type of the information of a variable in a program. I have repeated it. And the next part is instance. What is an instance? So what is an instance? Instance at a particular point of time, the data. Okay, in if you want a definition, it is the actual content of the data it is the actual content of the database at a particular instance. At a particular instance. So it is analogous to the value of the variable. Okay, now I'm going to say about this instance easily to understand. Now, instance is nothing but, I said you about a transaction from A to B where A is having 100. Now A wants to send a 50 and B is also having 100. So at the end of the transaction, the amount that is present in each balance in the each account is nothing but A is 50 and B is 150, right? So before the transaction it was 100 and 100. So after the transaction, at that particular instance, the amount that is present in the bank accounts in these two accounts is nothing but 50 and 150. So at that particular instance, if there is an other transaction taking place after that transaction, what is the amount? It shouldn't show the previous amounts, right? At that particular instance, whatever the transaction has been happened. Now I am giving you the examples of transactions. The updated data should be shown. So at that particular instance, and whatever data that has been updated should be shown and not the previous data. That is what I'm trying to say you here. So easy, right? The next part that I'm going to say you about is data models. Now there are different types of data models. There are 4 types of data models. Now first we are going to learn what is a data model. Okay. There are several data models for database design. There are mainly two models, ER models. Okay. ER models and the relational model. Okay, these two are important. The relational model. Okay, the other two are object-based data model and semi-structured data model. Okay, now remember these both. Okay. Now remember the entity relation. This is nothing but the entity relationship, the first one, and the second one is relational model. Okay, these both are important. Now the semi-structured data model can be also known as the XML. Okay. Now first, what is a data model? Okay. Now first I need to say about that. These are the types of the databases. So data model Data model is a collection of tools that you will be describing what data you want to store. What data that you want to store and the relationship between them. And relationship between them. Okay. So to understand it better in a better format, we use the data model. So these are the four four data models, out of which the first two are important. Okay. Now not only data, there might be data semantics, data constraints. Okay. Now in the relational model, I'm going to give you, there will be tables, and relationships between them. Easy, right? Easy to understand. Relationships between them. Okay. You know how our table looks. I'm going to show you in the next slide how the table looks and how the relational model looks. Okay. The next is the entity relationship model. It is a pictorial representation types of data storing, and the relationships. So this is about the ER model. So there is so from the entity relationship model, we can convert it into a relational model. Now I'm going to give you, there are other old models of these data models too. Now other old models are the network model. We don't use them anymore. The network model and the hierarchical model. Okay, now with the terms here, we are able to understand what it is. I mean, in a hierarchical manner, we are going to say about it, right? Okay. Now coming to the relational model. Relational model is just like this. Insert a table with some data in it. It is going to look something like this. See, each one has a column. I mean, there are a set of columns. These are the set of rows. And for the data is being mapped. So this is the relational model. Okay. Now I'm going to show you about this is the relational model. Now I'm going to show you about entity relationship model. As it is a diagrammatic representation, it is very easy to understand. Now I'm going to show you an example here. Okay. See, with two entities. Now before I say about this, let me say you what is an entity, what is a attribute and everything. As a I do not set you here. Okay, now I said you about the schema, right? I said you about the schema. The schema consists of tables. Tables in database is known as entities. Entities, so usually a table consists of rows and columns. So here we call columns as attributes and rows as tuples. Okay, so these are the terms that we need to remember. Entities, okay, entities, attributes, and tuples. Okay, every row is known as a tuple, every column is known as an attribute, and every table is known as an entity. Okay, now I'm going to say about the entity relationship model as I've said before. Entity relationship model. Now I'm going to insert a shape. Okay, here let's just for an example. Instructor. This is an entity, and the other entity is nothing but a table, as I said you in this slide. Now, instructor, and in this we are going to have department. Okay, here in the instructor, the attributes are ID and name. And here in the department, the attributes are department name and the building. Okay, now I'm going to show you how it is done. See, there will be a relation like this. Now, this is an entity relationship model. See, now what is the relationship among them? The relationship name is nothing but, okay, I'm going to use a pencil. The relationship over here is nothing but a member. Every instructor is nothing but a teacher here. We can say it as a teacher. Now every instructor must be a part of the department. So in every department there would be entities known the attributes as department name and department building. Now every instructor is a member of the department, there is no doubt, and the instructor entity, the attributes would be ID and name. This is about the entity relationship model. Okay, now there is entity relationship model. It looks like this. Now here, this is a relational model, and as I said here before, this entity relationship model can be converted into two or three tables, and we are going to see we we can understand that. Into a relational model, we can change. Into a table, into a whole table, we can change, right? So next I'm going to say about the object relational data model. Okay, object relational data model. Now, before I say about if you want the definition of an entity, before I say about the object relational model, if you want to say about the definition of an entity is a thing or an object in an enterprise that is distinguishable from the other objects. Okay, that is an entity. Now, a relationship is an association among the several entities. Okay, so that is nothing but entity relationship model, and it is represented diagrammatically by an entity relationship diagram. This is nothing but an entity relationship diagram. Okay, so every instructor must be a part of the department. So it is a one-to-one relationship. We call it a one-to-one relationship. And now, as I said you before, now we are going to see about the object relational data model. Okay, the object relational data model, it is a relational model. Okay, it is a flat and it has atomic values. The object relational data model, it is extends the relational data model by including the object orientation and constructor to deal with the data types. It allows the attributes of the tuples to have complex and tightly including non-atomic values such as nested relations. It is a little complex and people don't use it enough as a relational model and the enterprise and the entity relationship model. So object relational data model is used less, and the about the semi-structured model, it is an XML. So it is a sort of a Excel sheet. It is a little similar to an Excel sheet, but the database is more the entity relationship entity relationship data model is more convenient than the semi-structured data model. Okay, and as I said you before, network model and the hierarchical model are old models, and we are not going to discuss about it. That's it for today, guys. Let's meet tomorrow again. Do not forget to like, share, and subscribe. Don't forget to fill the attendance form, which is posted in the chat box and even in the description. Join all the links that are in the description below. Thank you.